Brendan Owens, Prairie Sun Solar. We're going to walk you through why it makes sense to have a battery system tied to your existing solar system. Some of the main reasons you would is you want to consume more of that energy yourself. You may want to have essential backup power. You might want to use your energy when you choose to based on time of use rates. And you want to be able to self-monitor what your energy consumption is. So here we have the SolarEdge full home battery backup system. A lot of people don't really know what is involved in batteries and what's the difference between a battery system and storage. So we'll kind of walk you through the steps of that here. So we have a 10 kilowatt hour battery. We have a 7.6 kilowatt hour hybrid inverter that allows you to be grid tied or go back to your battery. And then we also have the backup interface, which is basically your transfer switch. So when power goes down, you're no longer going to be connected to the grid. You're going to switch over to your battery and run your essential loads off that battery. This particular system is an essential load battery backup. A lot of people don't know how batteries work, and most people just assume if power's down and I switch to my batteries, I can run everything. There is a way to set that up to do it, but you're going to need significantly more batteries, typically anywhere from 2 to 3, where we just have a single battery. So we're going to be able to run all our 120 volt loads in an emergency backup situation. So your lights, your fridge, your freezer, your furnace fan, being able to run your heater, anything that's 120, you're going to be able to run for anywhere from 4 to 6 hours, or at least until power's back up. If you want to get into that whole home battery backup system, you're going to likely go from anywhere from 20 to 30 kilowatt hours, and then that'll let you run higher energy appliances. So to give you a rough idea of, well, what's a 10 kilowatt hour battery? So that's roughly 10,000 watts to be able to run, say, for an hour, or 5,000 watts for 2 hours, or 3,000 watts for 3.5 hours kind of thing. So it gives you a bit of an idea of what your energy use is. If you wanted to run, say, a hot tub is a pretty large load. It's a 240 volt load, anywhere from 40 to 60 amps. Like that's running anywhere from 3,000 to 4,000 watts. So if you wanted to just have a battery backup to run your hot tub, you're gonna need more than just one battery, because this single battery would probably be toast in about 2 hours. So it's really important to know when you're installing a battery backup system, what loads you actually need to run, and be able to switch between which loads you need. So with this system, this backup interface is going to connect to our transfer panel that's in the basement. We have the main electrical panel here, which is going to run absolutely everything in the house. And so we basically switch from the main panel to our essential loads panel that's in the basement. Here we have the essential loads panel. This is what's going to happen is when your battery and transfer switch over, they're switching over to these specific circuits. And the reason you do an essential loads panel is because your main panel might have too many 240 volt loads, and it's just going to drain your battery really fast. So we're only doing the loads that you absolutely need. For instance, this one, we're going to do some basic lights. We're going to do the fridge. We're going to do the freezer. And we're going to run your furnace fan. So then at least if power's ever down, you have those bare necessities. Your house has heat, your food's going to stay cold, and you're basically backed up until power kicks back in from the grid. Yeah, so some of the information you need to know in battery related systems, they're a little bit more complicated than, say, a grid tie system. Grid tie, you're just going to use energy as you produce it. Any excess goes to the grid. In an off-grid or battery backup situation, you need to know the specific loads of each of your appliances that you're tied to. So if you don't know those loads, for instance, you can go to your fridge, you can check the nameplate of it, you can look online, there'll be a sticker that'll say when it's running and cooling and the compressor fires up, it's gonna have a startup wattage, which, say, for easy numbers, might be 500 watts. And then when the fridge is actually cold and it's insulated and it's just plugged in and connecting on the electrical side, you might be running at 200 watts. And so each appliance is gonna have that specific sticker to know exactly what that is. If you can't find that information, you can actually do load tests. There's little plug-in adapters that you can just plug into the wall and then plug that circuit in, and it'll say it's running at 300 watts. And so to understand the difference between, what you have for your wattage of what it's using in real time and battery storage, so you're talking watts versus watt hours. So watts being that appliance uses 500 watts, watt hours is being If I run 500 watts for a single hour, that's 500 watt hours. So there's a little bit of difference between real-time energy and storage. So within your solar system, tied into the backup interface, there's also whole home consumption monitoring. So we're gonna monitor how much energy you're drawing in from the grid. You're also gonna have a reading of how much energy you're producing from the sun, and then you can see exactly how much energy you're consuming directly on a day-to-day basis. That's gonna allow you to understand your battery and what kind of backup power you might have by just knowing how much energy you're using on a daily basis. We got it all tied together in the SolarEdge app. It gives you a full interface which you'll have access to right on your phone, and it'll give you a really good detail of here's how much time you're gonna have backup power for, and that kind of stuff really helps to know. With this system being a grid tie hybrid battery backup system, so first and foremost, if you're connected to the grid and power's running as normal, your solar panels are gonna be producing your DC energy, and they're gonna be going first to charge your battery. You can program it to be able to either charge your battery first, feed your loads in your house first. You can have it so the excess energy, if say your base loads in your house are 3,000 watts that you're using throughout the day no matter what. Once your solar production is over 3,000 watts, you can then program your battery to charge that excess energy into the battery first versus sending any excess energy to the grid. If you're overproducing and your battery's already charged, that excess energy just goes to the grid and you get a credit at whatever the retail rate is of your utility. Here in Saskatchewan, the grid rate and export rate is about 7.5 cents a kilowatt hour, where if you use the energy directly, you're saving 15 cents a kilowatt hour plus GST, plus PST, plus carbon tax, plus GST on top of carbon tax. So some areas also have a municipal tax, which is an additional 10%. So the actual net rate, quite commonly in most areas, is about 19.1 cents a kilowatt hour. So anything that you use directly, you're saving 19.1 cents a kilowatt hour. Anything you send back to the grid, you get 7.5 cents a kilowatt hour. With this being said, there's a few different routes and options you can use your battery for. So one is emergency backup. Power's down, you just want to have backup power specifically for your home. So power's down, you want to make sure that you have backup power for your house. So if the grid shuts off, you automatically switch to your battery, you're running as usual. A lot of people also want to use it just because overnight they want to be more self-consuming. So any of that excess energy that you use or produce gets stored in your battery. When the sun comes down at night, you then flip over to your battery and you're going to use that energy at a 1-to-1 rate. So you're going to consume that energy directly rather than get the energy from the grid and pay for it, because you've already made it. The third reason some people might use it is there's time of use rates. In Saskatchewan, we don't have time of use rates, but in different provinces, there is time of use rates. So during the morning, you might have energy that costs 10 cents. In the peak of the afternoon in the summer, it might cost 25 cents. After 7 p.m. at night, it might come down to, say, 5 cents. So at that time, you can also use your battery to say, I don't even want to charge my battery from solar. I want to charge it from the 5 cents a watt cost at night. So it's going to be your lowest cost. And then when energy actually costs 25 cents, you then use your battery and you're going to basically be saving at 25 cents per kilowatt hour that you're using that energy. One of the neat things about the SolarEdge inverters and product line is they have all of their products in-house. So you have your battery that's a SolarEdge battery, you have your hybrid inverter that's a SolarEdge inverter, you also have the backup interface that is also SolarEdge. One of the other features that they do have within the hybrid inverter is you can also run the SolarEdge EV charger right off the inverter. And so you don't have to run a separate 240 volt cable to be able to run a new EV charger. You can just come right off the inverter, and it's a 40 amp level 2 charger. It's a really neat tool and function of the SolarEdge system. And the other nice thing too is the battery, the inverter, the backup interface, the EV charger, they all show under one app. So if you're a techie guy and you like seeing things, you don't need 5 apps, you have one. And if there's any issues at all within that system, you also just have one manufacturer to deal with rather than, the EV charger, the inverter, the battery being in all separate worlds. You have one point of contact, which is awesome. So when you're in the design phase of your solar system and you're wanting to add a battery, it's going to be really important to know where you can and can't put your battery. So there's going to be certain restrictions in different areas with regards to electrical code. Most people are going to install the battery ideally in your garage. It's generally a separate living space than your house. It can be installed in the mechanical room, say in your basement, but there's going to be certain fire rated codes that need to be met, which can add a little bit of cost to your installation. So ideally, it's always best to go in the garage. That also opens up the door with your inverter to be able to add an EV charger down the road. Most people are generally driving into the garage at night and going to want to plug in there. So if you are in that design phase, we highly recommend just making sure you look and see what the local codes are in your area. The garage is always a good spot, any kind of secondary detached area. And then if you are going into the house, it can't be in a bedroom or your living room, anything like that, for obvious reasons. But yeah, you can go in the mechanical room as long as you follow the right firewall protocol. Thanks for watching this video. If you have any questions in regards to battery systems, comment below. Feel free to ask any kind of question. We're happy to provide education, and we just want to make people a little bit more aware of what's going on in the solar industry.